Dear Regina Sailing, family and friends, and all others who want to learn more about stars. There is one star which I haven't been mentioning yet. It's so fantastic, it's so visible, it's so easy to find as long as you happen to sail on the northern hemisphere. And that's called Polaris. Polaris, of course, as all stars, we need to use twilight only in order to shoot the altitude of Polaris. But once we've done that, we can determine the latitude like nothing. It's really simple. So enjoy this very simple chapter.
If you happen to cruise on the northern hemisphere, one star in particular is very useful. It's called the Polaris. The Polaris is readily available all the time if you look up into the sky into the northern direction. And if you don't even know where north is, you could always use the plow to find the northern star or the Polaris. The plow is a nice little constellation that is easily found, and all you have to do is to prolong the stern of it 5 times, and then you get to the Polaris. And sometimes the plow is upside down, sometimes to the side. It depends on the time of the year as we see it. But one thing is for sure, the star in the middle seems not to rotate. And that's a pure coincidence that people on the northern hemisphere happen to have a very significant visible star if you prolong the North Pole up into celestial sphere, into infinity. There somewhere, many, many, many light years away, is a very bright star. And on the northern hemisphere, the whole stars seem to turn around that fixed point. It's not really fixed. Why? Because it's not really above us on the north, but almost. So it's very easy to use it for navigation, and the fact that it's not really in the north can easily be corrected with a couple of figures. So where is this North Star? Well, we found it in the sky, and I've drawn it here on my little Earth. So if you prolong a line through the North Pole up into the sky, you will find this beautiful star Polaris. And we are somewhere on our Earth, on the northern hemisphere. Well, here you can also see why on the southern hemisphere it's very difficult to see the Polaris, because the Earth is in its way. So you can only see it on the northern hemisphere. So we have learned and used so many times the value of the zenith distance. The zenith distance is the distance between us and the star. That should be quite a matter of course right now. And then we also know that our latitude, that is the angle between the equator and our own position. So if you look here, the latitude is very simple to calculate. If you take 90 degrees, because between the equator and the direction to the Polaris is 90 degrees, minus the zenith distance, and you already have the latitude. Isn't that beautiful? We do as we always do. We shoot up the star, we take the parallel beam coming from the star. The star is very, very far away, so these are really parallel. We can prolong the line, the blue line dotted into the sky above us. We find the zenith distance, the same angle we are looking for between the position above us and the direction of the star. Now this is very difficult to measure with a sextant, as we have said, so it's much easier to measure it along the horizon. So what we do is we use our sextant and measure the height of the star in relationship to the horizon. And here again, what do we see? Well, we've seen it so many times. The angle that we have here is 90 degrees minus the zenith distance. So if you use the beautiful calculation here to calculate what is the zenith distance up to the top left, you can see that the zenith distance is 90 degrees minus the angle, right? So we know what the zenith distance is, and by knowing the zenith distance, we just put it into our equation here, and we know that the latitude is 90 degrees minus the zenith distance, and the zenith distance is 90 degrees minus HO. So with a little bit mathematical knowledge, you know that latitude is the angle that we measure. So all we need to do is measure the angle between the Polaris and the horizon, and whoop, voila, we have our latitude. To sum up, latitude is approximately HO. Why approximately? Because the Polaris is only approximately in the north. What is the azimuth to the star if you want to find it in twilight? Because you need to use your hand compass to look into the direction where you are. Well, that is 360 degrees. Makes it simple, isn't it? So, of course, it's pointing to the north. And we said that the latitude is approximately the HO. So what you do is that you take your sextant, you preset it to your latitude. So the same angle should be put onto the sextant as your current approximate latitude. You look into the direction of the azimuth, 360 degrees. You should see a star hanging over the horizon there. And now you do measure it more precisely, more correctly. And you don't even need the time. That's fantastic, because that's how the ancient people, before they had clocks, the Vikings, I don't know, maybe they could determine the latitude by just looking into the sky to the north, because here comes the formula. Latitude is the angle plus a small correction A0 plus a small correction A1 plus a small correction A2 minus 1 degree. So here we are, no time involved. So all we have to know is what's A0, A1 and A2, and that's where we look on the Nautical Almanac. Here we are, and in the Nautical Almanac there is the Polaris correction. In my Nautical Almanac it's on page 274, so somewhere there it should be. So all you do is on the top line we look at the local hour of Aries, because the corrections A0, A1 and A2 is in respect of the local hour of Aries. So you look in the first line there, and for instance you have there between 0 and 9 degrees, 10 and 19 degrees, 20 and 29 degrees. So more precisely you go down a little bit the line to find the single decimals, and here you can find the correction for A0. Then you move further down into the table. Don't worry if you don't follow me here, we'll do it in an exercise in a second. And then you find the correction of A1. Then you go further down to correct it according to the month. That is A2. And in the very end, you just deduct 1 degree, as I said, and you have your latitude. And you can see it's only some very, very small corrections here, because the Polaris is really almost in the north. On the very bottom line of the table here, you have the azimuth, and it varies between 0.4 degrees and 300 and what does it say, 58.5 there in the corner. Well, that is just the azimuth, and it is more or less north, as you can see. So I think the azimuth is quite irrelevant. Look to the north, and that's where it is. So join me on these exercises, and you will find how simple it is, as long as you have done the homework to do the twilight calculations. So that's why the Polaris is also on my template for twilight predictions, twilight preparation. So I have put planets there, I've put a couple of stars there, and I've put a Polaris there. So when it is twilight in the evening or in the morning, then you can just be prepared to shoot planets and stars and the Polaris at the same time. So that is the work I have done to compile it all into one template. And I hope you will love this template when you are sailing day and night, crossing the oceans, and being a bit bored, maybe playing around with the sextant.